Electricity. Have you ever walked across a carpeted floor and then touched a metal doorknob, resulting in an electric shock? Why did that happen? Well, the answer has to do with electric charges. Atoms contain particles called protons, neutrons, and electrons. Protons and electrons have electric charge, and neutrons are neutral or have no electric charge. There are two types of electric charge. Protons have positive electric charge, and electrons have negative electric charge. Now, the number of protons and electrons are always equal. So the positive and negative charges cancel out, and atoms have no net electric charge. Objects with no net charge are said to be neutral, so they're not going to shock you. Electrons are bound more tightly to some atoms and molecules. So, for example, compared to the electrons in carpet atoms, electrons are bound more tightly to the atoms in the socks on your feet. So, when you shuffled your feet across the carpet, electrons were transferred from the carpet to your socks. And your socks have now built up electrons and have become negatively charged. When you went and reached for that doorknob, those excess negative charged electrons used your finger as a conductor and chuck, got you right on that doorknob. That is called static electricity, the accumulation of excess electrical charges on an atom. When an object is charged, those charges, whether it's positive or negative, cannot be created or destroyed. Usually what is happening are electrons can move from one object to another. According to the law of conservation of charge, charge can be transferred from object to object, but it can't be created or destroyed. Whenever an object becomes charged, that means electrical charges have moved from one place to another. Have you ever noticed how your clothes sometimes cling together when you remove them from the dryer? Well, these clothes are clinging together because of the forces that the electric charges exert on each other. Looking at this figure, it shows that opposite charges attract each other and like charges repel each other. The force holding electric charges together also depends on the distance between them, and the force decreases as the charges get further apart. So for example, with the clothes coming out of the dryer, as the clothes were tumbling around in the dryer, the electrons moved from some clothes to other clothes. And the ones that lost electrons became positively charged. So now when you pull the clothes out of the dryer, those positively charged pieces of clothing are going to attract or seem to stick to the negatively charged particles that lost all those electrons. Now when you pull those pieces of clothing apart, remember that the force holding these charges together depends on the distance between them. So eventually, when you pull the clothes far apart enough from each other, those charges will not attract or repel. Now, sometimes you will notice when you do pull your clothes out of the dryer and they're sticking together and you pull them apart, you might hear a little crackle and you might even see little electrical sparks. This also happens if you maybe lift a blanket over your head in a dark room or if you touch the metal doorknob after scuffing your feet across the carpet. This spark is caused by electrons moving from your hand to the doorknob or from one piece of clothing to another or from your head to the blanket. So how did these electrons move from one place to another? First, electrons can move through materials, and when they move through materials easily, that material is called a conductor. The best conductors are metals. The atoms of metals have electrons that are able to move easily through material. Electric wires, usually made of copper, because copper metal is one of the best conductors. Materials where electrons are not able to move easily are called insulators. Electrons are held tightly to atoms and insulators like plastic. Plastic coating around electric wires prevents a dangerous electric shock when you touch the wire. Other good insulators are wood, rubber, and glass. Now, when you shuffled your feet across the floor and touched that metal doorknob, your skin actually acted as a conductor when it touched the metal. By touching the doorknob, this can result in a transfer of electrons. The process of transferring charge by touching or rubbing is called charging by contact. You can also transfer charge by a process called charging by induction. You see an example of this if you were to rub a balloon on a carpet and then hold it near your hair. you will see your hair is actually attracted to the balloon. When you brought the negatively charged balloon near your hair, the extra electrons that the balloon picked up from the carpet repelled the electrons in your hair, causing those electrons in your hair to move away from the balloon, thereby leaving a positively charged area in your hair that is now attracted to the balloon, making your hair stand on end. As a result, the negatively charged balloon attracts positively charged particles in your hair. The rearrangement of electrons on a neutral object caused by a nearby charged object is called charging by induction. Your hair was charged by induction. The balloon will now cling to your hair, and the hair will be held there by an electrical force. Go ahead, blow up a balloon, try it for yourself, and now it's time to see what you know.